We will have some problem solved today on the course BCEDK 203. Some typical problems we'll try to solve and get ourselves cleared some of the doubts which may arise during our examinations. So the first problem what we are going to solve is based on the recent question paper which you might have seen. The problems on the line, I'm referring to question 1b. A line AB 100 mm long measures 80 mm in the front view and 70 mm in the top view. The midpoint M of the line is 40 mm from both HP and VP. Draw its projections and find its inclinations. So this is a problem. So normally we have solved problems with one end being fixed and other end being moved so that it was inclined to both HP and VP. Now here in this case we have the midpoint of the line M which is going to be the fixed point, so that both ends A and B are going to be the moving point, so that we have been given with the true length, the length of the top view and the length of the front view, and no angles have been given which we have been asked to find out. So we'll try to solve this. I'll open the Solid Edge, do the sheet setup. Okay, as usual I'll be having the XY line being drawn. Once the XY line is drawn, I'll be having the line being locked so that it will not move, and I'll use a text Arial of 3 mm height, so that we'll have XY, VP and HP. Once it is done, I locate the midpoint now using construction line. I'll be having the midpoint being marked. Okay, so for that I'll simply take the midpoint and take two lines, and I've been told that the midpoint M is at a distance of 40 mm from both the reference planes. So I'll keep this as 40 and this also as 40. So these are the front and top views, so I'll call it as M dash and M. Now I have been given with the true length, the front view length and the top view length. So we have been learned that the length of the front view is obtained by rotating the true length from the top view and directly projecting it. Similarly, length of the top view is obtained by rotating the true length in the front view and making it parallel to XY and dropping it down to the top. So that is the reason I'll take half the top view length, that is 35 mm, and I will start drawing a line. So that is from M dash, I'll take a line, this length is equal to half the top view length, so that is 35 mm, and from here I'll draw a vertical line. So this is the end project now, so that from M dash, if I cut an arc for half the true length, so that is 80 mm by 2 is nothing but 40, I should be able to get the true length point. So I will draw arc by center point method with M dash as center, with the radius equal to 40 I'll just draw an arc so that the intersection of this m dash with this arc is the half the true length. So from m, if I connect this, this is going to be b1 dash, b1 dash. Okay, b1 dash, the true length line. And passing through this, I can just have the line being drawn, which is nothing but my locus line. I'll connect the locus line to this point. This should be 40, it should not move. So by then now I can take half the true length of the front view. Okay, rather this true length was 100. Okay, that is the length. I have to make it as 50 then, half the length is 50. And once I get this locus of B, in the front view, I can mark B dash, because M dash B dash shall be 40 mm. M dash B dash shall be 40 mm. So I can draw one arc with M dash as center. Rad is equal to 40. Then it will be the arc length can be made as 40 mm. So this intersection is the required point, which is nothing but M dash to B dash. So this is going to be B dash, the front view point. Once I obtain these two things, now the rest of the things are very easily can be completed in the front view. Since this is one half, the remaining half can be simply extended. Okay, simply extended, or I can just concatenate it. So I'll draw one line and I'll make these lines equal. So this line equal to this line, and also I can make them collinear. So this line collinear to this line. So this will be the front view, and this point will be A dash. This is A dash, and similarly I can have another line for the true length being extended. I'll make it equal this half, rather I'll make this line equal to this line half and make it collinear, this line collinear to this line, so that both these will be on the same line. I can connect them any one of the points. So that you can see that they'll be on the same line. So this completes the front view of the given problem. This line type I can make it as center line, or the cutting plane line, which is nothing but the locus of A in the top view. Locus of A in the top view. Once it is done, I can just process further to get the top view completed. I'll draw projection lines. I'll draw the projection lines from the true length points and the top view points. Because I know that the top and front view shall come in the same vertical projectors and projectors. And I know that the length of the top view is 35 into 2, that is 70 mm. So I can draw two arcs of size 35 mm, one onto this side and another onto this side. Draw radius of 35 onto both sides and connect them with a visible line. Which will pass through the intersection point. And we'll find that it is exactly passing through the midpoint M. Now then you can draw the locus of the top view, locus of A and locus of B, and try to connect them. I'll use connect. So that I get this is the locus of B in the top, locus of A in the top. Lastly, I need to fix the true length in the top view. I'll take arc from this end point. I'll draw the arc length of 50 mm. Again one more arc. Draw the arc with M as center, radius of 50. So where this is intersecting, that will be the two more true length points. The top view points are A and B. The true length points are A2 and B2. I will join A2 and B2. Of length 100 mm. So now then the problem is solved. We need to find out the angles now. We need to find out the angles, the true angles and the apparent angles. We will find out the angle between the true angle in the front view, that is theta, 46 degrees, and the true angle in the top view. If you want to get, I need to have a reference line to be drawn. I can draw the reference line and I can get the angle, the true length with VP is 37 degrees, that is phi. Then the apparent angles I can find out. Apparent angle in the top and in the front, that is alpha is 63 degrees and beta is 59 degrees. So this is how we can complete the given problem. Alright, the one more problem which I want to solve is the problem of isometric projection, which you can see here. Question number 3 in module 3 is given. Following figure shows the front and top views of the solid. Draw the isometric projection of the solid. Basically, there is a mistake in the question. This is the front view. If you take this is the front view, basically this forms the side view. Okay, it forms the side view from left, so it is a left side view, so it is not the top view. Nevertheless, we'll try to solve it. Seeing the side view, you can see that the block is, there are two blocks. One is having a width of 15 mm, okay, height of 60 mm is the block, okay, and length of 45. So it is a 45 by 60 by 15 is one block, and the second block is 15 by 15 by 25. So we can start drawing that. I'll insert a new sheet, do the sheet setup. As usual, we'll have to draw the axis. Before that, I can have a reference line. This is my reference line which I am going to lock. Then I'll draw two 30-degree lines which are my reference lines. Two reference lines I have drawn. Ensure that this is angled at 30 and the other side is also angled at 30. So once I have drawn the reference line, now I am going to draw the first block, that is a block of length 60, height 15 and width 25. So the length will come here, the width will come here, and height of 15. So the length is 60. So I'll draw a line of 60 mm. Okay. And another line whose length is going to be 25, and I'll make it parallel to the axis. Parallel. I'll make not equal, parallel. This line parallel to this, and I'll take the dimension of this as 25, and then I'll complete the base. Again I'll make this line parallel to this. So the base is done. Then the height of 15 here, this height of 15, I have drawn this 25 and 60. Now the height of 15 I'll draw. This length is 15 mm. I'll draw 3 more lines. I'll make them all parallel and equal. These are equal. They are equal. Equal. So that I can get the top being connected. Yes. So this completes the base. I will give the dimension on the other side later. Now from this side, now I have to have the second solid, which is nothing but a block of 15 by 60 by 45. 45. So that means from the middle of this block I have to take 22.5, 22.5. So total is 10 plus 10, that is 20, plus 25. So that is going to be 45. So from this end I will have to draw for 10 mm. It's easily can be drawn. I will make them collinear. This line collinear to this line. This line collinear to this. So there is a mistake. Collinear. This collinear to this, and I'll take this collinear to this. Again I am making mistake of making it horizontal or parallel. This line segment I have to make collinear. This collinear with this, and the length of these two I have to maintain 10 mm. This also 10 mm. So that from here to here it is 25 plus 10 35 plus 10 45. Okay, so this has been taken care. Now the width of 15 and height of 60. Okay, so from here I'll draw a line, 2 lines rather, and I'll make them parallel to the axis. Parallel. So this line parallel to the axis and this line parallel to the axis. And if I complete this, it's not only parallel, I have to make them equal also by giving the dimension for this is 15, and I make this side equal to this, so that if I connect end of this, this line will have dimension of 45. So this is now 15, 45, and now the height has to be given, which is 60. So from these corners we will draw 4 lines. And I'll make all them equal. This equal to this equal to this, and this equal to this. And I'll give dimension for one of the side. So I'll make it 60. So then automatically this has become 60, 60 and 60. I'll connect the top. So this is how it will be looking like, and I'll have to make some of the lines thick. So the front face of all this will be thick. This is also going to be visible. This line is visible. This they are visible. Visible. Now here this line I need to split, so I'll go for split. I'll split this line at this intersection, and I'll make this line also visible, and I'll draw one line from here to here. So this completes the problem, but I have to scale it down. I'll use the scale. Before that I have to save this. So to go for scaling, here it is scale. I'll include the fence, and I'll give the scaling factor 0.816, and my reference will be this point. So this is how it will be looking like. I'm not supposed to dimension it, so I'll remove all the dimensions after confirming. I'll only retain the angles of the axis, and I am supposed to keep the lines of construction. I'll keep the construction line as it is. So this is how you can solve problems. One more problem we'll try to solve, that is on module 3 only, which is isometric projection. There is another part in that module wherein they'll give the isometric projection and will ask to draw the first angle projection, namely the front and top view as well as sometimes the side views. So we'll draw for this particular problem. It's given using first angle projection, draw the front view looking in the direction of arrow shown down, it is here, top view and the right side view of the given machine component as shown in the figure. So 3 views they are asking. So we'll try to draw the orthographic projection. Now these are direction for the front. So which are the dimensions visible? I can see these 2 part of rectangles, width of 45, height of 15, then this height of 60, and I can see this width of 15. So that will be L shape. So that is going to the front view, and in the top view I am going to see the top surface, that is 60 by 15, and I will not be able to see the depth here, and I will be able to see this part as well as I will be able to see this middle portion. So we'll try to draw that. I'll have a new sheet being taken, and as required, let me draw the front view first. For that I'll draw the XY line. So this is my XY line. This is my VP and HP. Since the right side view is asked, I'll have to draw the left profile plane. So that means I'll have a X1 Y1 line to be drawn like this. So this will be my X1 Y1 line, so that I'll have my VPHP brought to this side. So this is going to be my LPP. This is LPP, the left profile plane. I have to log the XY line as well as X1 Y1 line. Log this XY and X1 Y1 line. Okay. So to draw the first, that is the front view, I can see this 45 length, height of 15, and this height of 60, and this width of 15. So I'll draw accordingly. Anywhere on the line I can start. I draw a line So this length is going to be 45 and the height is going to be 60 and I'll have a width of 15 then this height is there, that is 15. So I can draw one more line from here upwards for 15 mm. Now I have to extend this. I'll just draw like this, two lines and trim off. So this is this part, and now I'll be having this inclined line. That means this and these lines are going to be visible as connected. So in the front view I can see this being connected. Now we'll have to draw the top view. To draw the top view, I'll just draw the projectors from various points. I'll move this dimension up. Now in the top view, what I can see is I can see this 60 by 15. First I can draw that. I can draw line of visible mm. And the width of 15. You can see this width of 15 here. Similar way I can draw this box. So this is done now, and now I have the other part. This is total is 45. So this I can see 45. This length is 23 plus this width is 14 plus on the other side it should be how much? 14 plus 23, 47, and other side it is 60. So 60 minus 47 is 13. So it is 23 plus 13. So it is 36. Rather it is 23. 23 plus 23 is 46 plus 14 is going to be 60. So I'll draw visible lines for the remaining part. Okay, now I'll have to have this 23 and 23 to be marked. So from this end I'll mark a line. So this distance I have to keep. Distance between this line and this line is to be 23, and draw one more line. And this gap shall be 14, and obviously this gap is going to be 23. So this is a detail what you can see in the top view. This is how the top is going to look like. To draw the side view, now the procedure is you have to draw a 45-degree line from the intersection of xy and x1 y1 line towards HP. Towards HP. And this is 45 degrees. You need to just rotate all the lines from the top view onto this 45-degree line. I'll extend it a little bit. I'll project all this onto this 45-degree line. And project it to the side of VP. Move up. And afterwards draw horizontal projector from the front view points. Draw horizontal projectors. So now we'll have to visualize now. In the side view now, you can see this part of 60 by 15 as full. You can see this width. Basically, if you take the dimension of this line too, rather this line, an odd angle, distance between from this line to this line, it will be, sorry, I have to take between this and this, it's going to be 60. So this 60 by 15 is going to be completely visible. So I can make this as a block. Okay, I can split this. At this point, and make them thick lines. And also I need to have this to be split. so that I can make this visible, and I'll draw a visible line indicating the base. Next, what I can see is a frame, the outside frame. So the outside frame shall be visualized. The outside frame shall be visible. This has to extend to next. I'll trim this off, and this part is also going to be visible. And finally, I'll be able to see this width of 15 in the middle, or rather 14 in the middle. So this shall be made thick after splitting. Split this, so that make these two elements as visible. So this is how the problem has to be solved. This projector I don't require to be thick here. Right, this is how the right side view on the left profile plane, the front view and the top view shall be drawn for this given problem. So thank you.